finding the LCM using the division method. This is another way to find the LCM of numbers, 2 or 3 or more numbers. Now, to find the least common multiple, also called the lowest common multiple, or LCM, or 2 or more numbers, we're going to use the division method. First is find the smallest prime number that is a factor of at least one of the numbers. What do you mean by that? We'll see in a few. Then after now, if any number, given number, is a multiple of that number, you divide it, write the quotient or the answer below it. Bring down any number that cannot be divided by the prime number without remainder. Then continue the steps until only ones are left in the last row. Let's do a few examples. Example 1, using the division method. Find the least common multiple of 5 and 14. Now, you draw some columns and some rows. And above you list 5 and 14. Now, we're going to find the smallest prime number. We know about prime numbers, right? Prime numbers are numbers that only have 2 factors, 1 and itself. All right? So look at these two numbers, 5 and 14. Now, I'm going to start with one number, but you say you could probably start with another number because look at here right now, we know 5 is prime number. But let's see how this goes. We start with 5. So we divide, right? It says we're going to divide number here by a number outside, but the prime number, and see if there's a remainder or not. So we start off 5 divided by 5. How many times can 5 go into 5? Yes, it can go into 5. How many times? And it goes into it 1 time. Now right here we already stop for the number 5, but we have to continue until we have all ones at the bottom. All right, so can 5 go into 14? No, it can't without a remainder, so we bring the 14 down. Now we're going to continue steps until there's only ones left in the last row. Now we're going to use 2 because from our tables you can see 2 can go into 14. All right, now we'll start off again. 1 divided by 2, can we? No, we can't. So we leave it as it is and bring the 1 down. Then we start to divide 14 divided by 2. Timetables, it can. What times what gives us 14? 7. 2 7s are 14. So we continue going downwards. Now what number here can divide into 1 or 7? Well, you know you can't go into 1 anymore. So what number can divide into 7? And hold on. 7 is a special number. 7 is also prime. So we use 7 in this case. Can 1 be divided by 7? No, it can't. So the 1 comes down. And can 7 be divided by 7? Yes. How many times can 7 go in 7? 7 times 1 is 7. It can go into it, so it's 1. Now we are finished right here. All the numbers at the bottom and the rows are 1s. What do we do next? We're using these numbers over here in the column and multiply them in each other. So the LCM of 5 and 14 will be 2 times 5 or 5 times 2, then multiply by 7. So in this case, we say 2 times 5 multiplied by 7. 2 5s are 10, and 7 10s would be what? Yeah, got it, 70. So the LCM of 5 and 14 is 17. Now you decide if you rather this method or the list method. All right, let's do a few more examples of the division method. Example 2, find the least common multiple of 3, 9, and 12. 3 numbers this time. Same rule. Put your columns down. 3, 9, and 12. Same thing. Find the smallest prime number as a factor of at least one of the numbers. Now, you may ask yourself which one to use first. It all depends on you. All right? But, we start with 2. Can 2 go into 3? No. Without a remainder? No. So, we bring the whole 3 down. Can 9 divided by 2? No. Can't. So bring the 9 down. Can 12 divided by 2? I can hear you saying yes. Yeah. 2 into 12 or what can I multiply by 2 to get 12? The answer is 6. So we continue. As it says, continue the steps until there are ones left in the last row. We divide by 3. Again, another prime number. So can we divide 3 by 3? Or 3 times what is 3? 3 times 1 is 3. So we bring the 1 down. And as you see now, we start to get 1s in our rows. So we are almost close to finding the answer. Can you divide 9 by 3? Yeah, remember division is the opposite of multiplication. 3 times 3 is 9. So yes, 9 can be divided by 3. And the answer will be there, 3. Move on. 6 divided by 3. Yes, it can. And you divide 6 by 3, you get what? 2. 3 times 2, 8, 6. See how important tables are? Continuing. We haven't done as yet. Move along. We continue using 3. Can 1 divided by 3? No. So we bring the 1 down. Can 3 be divided by 3? Yes. 3 into 3 give you 1. 3 times 1 is also 3. Can be 2 divided by 3? No, we can't. So we bring the 2 down. We are not done as yet. All these numbers have to be 1s. What number can we use here? Aha, I'm guessing 2. So 1 divided by 2? Nope. Bring the 1 down. 1 divided by 2? Nope. Can 2 be divided by 2? Yes. So here's 1. 2 times 1 is 2. So we have all 1s at the bottom. So we are finishing up. So we're going to multiply these numbers over here. Remember we did prime factorization? Start with the lowest numbers first. Remember that. So the LCM of 3, 9, and 12 would be 2 times 2 times 3 times 3, giving you 36. 2 2s are 4, 3 4s are 12, 3 12s are 36. Very good.